Hello everyone, in this NetBioDyn tutorial we will talk about alcoholic fermentation. Firstly, I will present you the alcoholic fermentation, then I will explain the principle of this reaction, after I will focus on brewing fermentation. Finally, I will show you the modeling with NetBioDyn. Alcoholic fermentation is the basic reaction of the alcohol production. This reaction is permitted by the yeast metabolism. It converts the sugar into alcohol. This reaction permits the production of the flavor of the drink. The aim of this tutorial is to realize a modeling with NetBioDyn, which permits a better understanding of NetBioDyn and alcoholic fermentation. Yeast metabolism is based on two metabolic pathways. In aerobic metabolism, the glucose is metabolized by yeast in CO2 and H2O. This reaction is involved in yeast division. In anaerobic metabolism, the glucose is metabolized into alcohol and CO2. Yeast used in brewing fermentation mostly have an anaerobic metabolism. In brewing fermentation, there are several types of fermentation, for example, low fermentation or high fermentation. Those different types of fermentation use different types of yeast and produce different types of beer with different organoleptic quality. Low fermentation uses Saccharomyces euvarum and takes place between 8 and 15 degrees. This fermentation type is specific of lager. In this type, yeast form a deposit after inactivation. To realize the modeling with NetBioDyn, you have to create the entities. Then you have to create behaviors. It's very important to well design the behaviors you'll give to the entities. Don't design them in terms of biology, but think of the global similarity between simulation and biological modeling. Here is NetBioDyn software. NetBioDyn is made of 6 parts. This one is used to create the entity. This one creates the behaviors. The simulator runs the modeling. I have already started to make the modeling of low fermentation, but the entity oxygen is missing. I'll show you how to add oxygen in the modeling. I choose the entity oxygen. An entity have a name, half-life, a color and a description. I have chosen infinite half-life for oxygen. I choose the tool I want. Here I choose spray, and I add the number of entity I want in the simulator. Now I will show you several interesting behaviors. The first behavior I'd like to show you is the movement behavior of Saccharomyces euvarum. Saccharomyces euvarum has a 50% probability to move in all directions. Now watch the aerobic metabolism of Saccharomyces euvarum. In the presence of water and O2, Saccharomyces euvarum gives 2 entities Saccharomyces euvarum and 1 H2O. I choose to consider the production of CO2 as negligible. In anaerobic metabolism behavior, an entity Saccharomyces euvarum in the presence of water produces ethanol and CO2. The inactivation of Saccharomyces euvarum took place in presence of ethanol. Indeed, every type of yeast has a rate of alcohol leading inhibition. I choose 10% as inhibition probability. I run the modeling. After inactivation, the entity inactivated Saccharomyces verum form a deposit here. That's why I create a behavior where the entity Saccharomyces verum in the presence of bottom form a deposit. Here you see the curve who represent the number of entity in the modeling. I will show you the entity deposit Saccharomyces verum. Here is it inactivated deposit Saccharomyces verum. Thank you for having watched this tutorial.